Okay, so here we've got the notes for section 2.4, rate of change, tangent lines, and sensitivity. So our objectives, you can read those yourselves. I'm not going to read them at you. All right, so average rate of change of a quantity over a period of time is the amount of change divided by the time it takes. So essentially it's the slope of the line, delta y over delta x. So example 1 says find the average rate of change of x cubed minus x over the interval 1, 3. Now be careful with intervals, because intervals give you two x values. So I need to figure out the coordinates. I need my x, whoops, that's not what I'm gonna do. My x1 comma, what's the y value? And my x2 comma, what's the y value? So I can find the slope. So to find the y value, you plug your number into your equation. So if I plug 1 in for x, I get 1 cubed minus 1, which is 1 minus 1, which is 0. If I plug 3 into my equation, I get 3 cubed minus 3, so 3 cubed is 27. 27 minus 3 is 24. So to find the average rate of change, I just find the slope between those 2 points. So y2 minus y1 over x2 minus x1. Oops, x1 is 1. So that's 24 over 2. So the average rate of change is 12. The slope of the line that connects those 2 points. Now, the average rate of change is what's referred to as the slope of a secant line. A secant line is a line that crosses your curve or line, whatever you have, at 2 places. So if you think about some goofy curve, connect 2 things, that line is a secant line. And that's essentially the slope we calculated. Okay, so tangent to a curve, the rate at which the value of the function y equals f of x is changed with respect to x at any particular value, x of a, is the slope of the tangent line. So a tangent line touches a curve at exactly 1 point. So it does not cross through the curve. So that line is a tangent line. So there we go, the method of defining tangents to produce formulas for slopes of curves and rates of change. So you start with what can be calculated. So you find some initial value p and some point q nearby. And then what you're going to do is you're going to let q move towards p and keep recalculating the slope. So essentially you're finding the limit as q moves closer to p. So you define the slope of the curve at p to be this number and define the tangent curve to be the line with that slope. So what that's saying is, so say I have some goofy, that's a quadratic, so here's point p, so that's the point that I want the slope at, and there's some point q over here. So I'm going to find the slope, call that q1, the slope between p and q1, and then I'm going to move q1 closer and closer and keep recalculating the slope. And I'm going to watch the pattern of these values. And if they start to approach a given number, that then is my slope as q gets closer and closer to p. So which is this kind of like using the table method for the limits. So example 2 says find the slope of the parabola y equals x squared at the point 2, 4. Write an equation for the tangent to the parabola at this point. So, so here's p. It's at 2, 4. So I need some q's, and they're going to move closer and closer to that point. So let's just take 3 q's. So we'll set the first one, q is 0. So when q is 0, y is 0. Then we'll say q will be 1, y will be 1. And then we'll say 1.5. In this case, it's 2 1/4. And let's see here. So 0, 1, let's do one more, q4, we'll call 1.75. And the y value there is 1.75 squared, or 3.0625. So what I'm going to do now is just a whole series of slopes. So between p and q1, between p and q2, between p and q3, between p and q4. Let's see if they level off at a value. So for p and q1, it's going to be 0 minus 4 over 0 minus 2. So negative 4 over negative 2, so that slope is 2. For p and q2, it's going to be 1 minus 4, 1 minus 2. So that's negative 3 over negative 1, so that's 3. For p and q3, that's going to be 2¼ minus 4 divided by 1½ minus 2. So 2.25 minus 4. So on top I have negative 1.75. And on the bottom I have 0.5 negative. So that's 3½ between P and Q4. That's going to be 3.0625 minus 4 over 1.75 minus 2. So 3.0625 minus 4 on top is negative 0.9375, and on bottom negative 0.25. So this all comes out to be 3¼ Now, if you look at your values, I go 2 to 3, so that's an increase of 1. I go 3 to 3½, that's an increase of a half. 3½ to 3.75, an increase of a quarter. So the next increase is probably going to be an 1/8, a 16th, a 32nd. So what this actually is, the slopes here, m is approaching 4. Because it is growing, but it's slowing down. And if I kept doing my values, I would get that value. Now the second part says write an equation for the tangent to the parabola at this point. So that's using point slope form. So y equals m, x minus x1 plus y1. So y equals 4, x minus 2 plus 4. So 4x minus 8 plus 4. So y equals 4x minus 4. So this line will touch the parabola at that point. So 1, 2, 1, 2, 3, 4. So graph's not very good. So it'll touch the curve just barely. But that's the point. Okay, slope of the curve. Slope of the curve, y equals f of x. So we have this formula. So essentially what this is saying is that instead of talking about Q1, Q2, Q3, I'm measuring the distance. H is measuring the distance between point P and point Q. So as H gets closer and closer to 0, point Q moves closer and closer to point P. So if you think about it once again, we'll draw my level of the parabola. Here's point P, here's point Q. So it's saying this distance is H. And what you're going to do is H is going to get closer and closer to 0 as the point slides towards it. Okay, so down here, let f of x equals 1 over x. Find the slope of the curve, x equals a. So we're going to use this handy-dandy formula. So we have the limit as h approaches 0. So f of a plus h just means replace the x with a plus h. And f of a is just the original equation with a plugged in for it. And then all over h. So I need to combine these fractions. I need a common denominator. This one needs to get multiplied by a. This one needs to get multiplied by a plus h. So this one's going to become a over a squared plus ah minus all over h. So like terms, so a minus a, that goes away. So I just have negative h on top, negative h, and on bottom a squared plus ah all over h. So to divide by h, what you end up doing is you invert it and you multiply. So times 1 over h. So these h's cancel, leaving me 1 over a squared plus ah. But I'm doing the limit as h goes to 0, which means I can do a substitution step and plug 0 in for h. So this just becomes 1 over a squared. So that's the slope of the curve at x equals a, 1 over a squared. So now the reason I can't do substitution right from the start is that would force me to divide by 0. I'd end up with 0 over 0, which doesn't do me anything useful. So here it says, where does the slope equal negative 1/4? Well, that's my equation for the slope, 1 over a squared. So 1 over a squared equals negative 1/4. So so let's see, we'll do cross products. So negative a squared equals 4. We have a problem here. Okay, I figured out the problem. Problem is way up here. I lost my negative sign. So those h's cancel, but that negative's still there. So it should be -1 over a squared. So should have like that. So that. So now the negatives cancel. A squared equals 4. So to solve, I take the square root. So I get 2 solutions. So the slope will be -1/4 at +2 and at -2. So it says, what happens to the tangent of the curve at the point a comma 1 over a for different values of a? So it's just saying what's going to happen to this value. Well, tangent is 1 over a squared, so it's the negative square of the reciprocal. So that's just that formula, the negative square of the reciprocal. All right, normal lines. Normal lines are perpendicular to the tangent, so they run through the line and run through the curve and form a right angle with the tangent line. So normally to find a normal line, you have to find the tangent line first. So example 4 here says write an equation for the normal to the curve 4 minus x squared at x equals 1. So the first thing I need to figure out is the slope of my tangent line. So that's using f of a plus h. Now, so f of a plus h is 4 minus, and that's my, whoops, off the screen. That's my a value, 1. So 1 f of a plus h squared minus, no, so f of a is going to just be 3. You plug 1 in, so 4 minus 1 squared is just 3. This is all over h. So this is going to become, so that's a FOIL problem, so I'm going to cheat and work it out in my head. So you have that. That's the FOIL. So 4 minus 1 minus 2h minus h squared minus 3 all over h. So this negative sign out front here goes through all of those terms. Okay, so down here, if you look at your numbers, they all cancel out. 4 minus 1 minus 3, those are all gone. So I'm left with the limit as h approaches 0 of negative 2h minus h squared all over h, which becomes, h's can cancel, negative 2 minus h. So as h goes to 0, the whole thing just becomes negative 2. So that's the slope of my tangent line. So since the normal line is perpendicular, it's the reciprocal. So perpendicular slope, is the opposite reciprocal. It's 1/2. So the equation y equals mx minus my x value, 1, plus my y value. So to find the y value, you plug x into your equation, you get 3, it's that number there again. So y equals 1/2 x minus 1/2 plus 3. So y equals 1/2 x, that's 6/2, so plus 5/2. That's the equation for the normal line to the curve through x equals 1. Okay, you can also use this to find speed. So instead of x, you just use t for time, but it works the same way. So it says for the function 2t squared minus 1 at t equals 2, interpret the answer, blah, 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 blah. So I'm going to do the same setup. So the limit as h approaches 0. So there's my equation. So 2, and then my a value. So 2 plus h squared minus 1. So that's f of a plus h. Minus f of a is what I get when I plug, or f of t in this case. So 2 squared is 4. 4 times 2 is 8. Minus 1 is 7. All over h. So this becomes 2 times, do the FOIL, 4 plus 4h plus h squared minus 1 minus 7. Distribute the 2. Let's see here, we got 8 plus 8h plus 2h squared minus 1 minus 7. If you notice, once again, all the numbers go away. 8 minus 1 minus 7. So back over here, the limit as h approaches 0 of 8h plus 2h squared all over h. This is going to become the limit as h goes to 0. H's cancel of 8 plus 2h. H goes to 0. I get just 8. So there we go. That is the speed of the object at 2 seconds if that gives its position. So feet per second with your units. All right, so example 6, find the speed. So that equation was y equals 16t squared. Tells you how far it goes. So same setup. So my time is 1. So we're going to have the limit as h goes to 0. So 16, 1 plus h squared. That's my a value. And then minus 16, what I get when I plug 1 in, all over h. So limit as h goes to 0, so 16 times 1 plus 2h plus h squared. That's doing the FOIL. Do your distributing. If you've done it right, the numbers should cancel. So I have the limit as h goes to 0 of 32h plus 16h squared all over h, which cancel your h's, 32 plus 16h. H goes to 0, so this all just comes out to be 32. So 1 second in, that rock is going 32 feet per second. So sensitivity just measures how you respond, so essentially it's the same kind of thing. So a patient enters a hospital, temperature of 102, and is given medicine to lower the temperature. It's a function of dosage measured in milligrams. The patient's temperature will be, so temperature in terms of the dose is 99 plus 3 over 1 plus d. Interpret the sensitivity of the patient's temperature to the medicine dose when d is 1 milligram. So this is my a value. So same problem. Limit h approaches 0. So f of a plus h, 1 plus h, because that's what d becomes. So that's a plus h minus f of a. So that's what I get when I plug 1 in. So that's 99 plus 3 halves. So 99 plus 3 halves, that's 99 plus 1.5. So that's 100.5 all over h. So 99 plus 3, 2 plus h, minus 105 all over h. So 99 minus 105, 99 minus 100.5 is negative 1.5. So that's negative 1.5, so that's negative 3 halves. So I need a common denominator. So this one gets multiplied by 2 plus h. So that's 6 plus 3h all over 4 plus 2h. And this one gets multiplied by just 2, so 6 over 4 plus 2h. All right, so now I can add them. So negative 6 plus 6, those go away. So I have 3h on top, negative 3h, because that negative goes to the 6 and to the 3h. And on bottom, 4 plus 2h all over that h. So negative 3h, 4 plus 2h times 1 over h, do the reciprocal step. Negative 3 over, h's cancel, 4 plus 2h. So when h goes to 0, this all becomes negative 3/4. So it's going to decrease their temperature by 3/4 of a degree. And that's what all of that math came down to. And that, finally, brings us to the end of the section.